we have position. What can we do to get velocity and acceleration? Well, we write our variables here. We have S, V, A. If we need to go down the chain, we take the derivative. If we need to go up the chain, we integrate. In this problem, we're going down the chain. So we need to take derivatives. So, first derivative, to get velocity, we know v equals ds dt. That was one of our fundamental relationships, and actually we can just write them all over here. We'll have v equals ds dt, a equals d squared s dt squared equals dv dt equals dv ds times v. So to get velocity, we know we have position, we have time in the equation. So this position, time, we know we can get velocity. So if we take the derivative of a constant is 0. So we skip that one. And then we have sine of 2t. Well, derivative of sine is cosine. But we have to use chain rule because the thing inside of the parentheses is also not a constant. So the derivative of 2t is just 2. So review chain rule, if you're not familiar with that. That is dy dx, sorry, dy dt equals dy dx dx dt. Okay, that's chain rule. So in this case, instead of y, we were doing s. So we call this theta. Then basically we had ds dt equals ds d theta dt. So chain rule, because this 2t is not a constant. So then we solve out, we get v. So this is the answer for v. V as a function of time. So now to get acceleration, we're here. We need to go one more down, so we can just take derivative again. We have the velocity equation, we have time, so we can use a equals dv dt. So a equals dv dt. So we have this 2, and then the derivative of cosine is minus sine. I'll put the negative out here. Sine of 2t, but we have to use chain rule again, so multiply by 2. So that equals -4 sine of 2t. Now, if position is in meters, velocity is going to be in meters per second, and acceleration will be in meters per second squared, because you're getting another t on the bottom each time. If we want to graph that, let's see what this looks like. So you'll need to be able to visualize this stuff with a graph. And once you get an equation, you should be able to plot it. Or if you're given a graph, you should be able to get the equation from the graph. So let's see, if we start with position, let's see, that can be green. So s equals 3 plus sine of 2t. So let's say this is 3. And then we know that for every 2 pi for the sine function, every time theta is 2 pi, you get a whole revolution. But 2 pi is double of t. So every time t is pi, we'll get a whole revolution. And we know that it starts at 3. So the mean is 3, the amplitude is 1 because it's just, that's 1 times sine. So we know go up, go down, 1 revolution, 2 revolutions. So that is position. Now velocity, but it's a cosine function, and its amplitude is 2. So let's say this is 2. So this one is going to start at the top and end at the top, and it will cross underneath the axis. So that's velocity. And then finally, acceleration. -4 sine of 2t. Well, we know the sine function should start at 0, and normally it would go up. But instead, since this is a negative, it's going to go down. And then the amplitude is 4. So 4, -4. So we know that we'll start here. We'll cross here. We'll cross here. And it goes down first. So down, back to the center. So that's what this function looks like.